This is a video to show you how to get started with the DT80 CANgate combination. In this example, we have the following hardware connected. We have connected the logger to the PC and the CANgate to the logger using the supplied cable. We have connected a CAN bus J1939 diagnostic connector to CAN bus port 1 of the CANgate with the wiring as is shown. These diagnostic connectors are present on all CAN bus systems operating J1939 protocol. This would include virtually all large trucks, agricultural machinery, fixed engines and marine systems. For this example, we have also connected a Garmin GPS 18 5Hz to the GPS port of the CANgate. We are going to measure the following. Firstly, we are going to measure engine fuel rate. From the J1939 documentation, we can see that this is PGN number 65266. There are a number of other measurements available in PGN number 65266. These may or may not be available on the particular system. Next, we are going to measure engine RPM. This is PGN number 61444. Again, this PGN number has a number of measurements associated with it. In this case, instead of just measuring the instantaneous value, we are going to use the CANgate to measure the average, the maximum and the minimum between samples. Finally, we are going to add GPS measurements. The Garmin GPS 18 5Hz we are using has a default baud rate of 19200 and transmits by default the GPGGA string. We use this string to record latitude degrees and minutes and the longitude degrees and minutes. We will also record our current heading in degrees and the GPS status. We have DLogger running and we have created a connection to the logger. If you are not sure of this process, check the other DT80 videos. We will arrange the pages. I close all DLogger windows I'm not using. Select the DT80 programming window first, prog1.d80. Click row R1 and column signal. This opens a list of signal types. Select CANgate. The first time the CANgate is selected, a CANgate configuration box is opened. In this panel, we set what hardware we have connected to the CANgate and how the CANgate is configured. We use all default parameters for the connection of the CANgate to the logger. In this instance, we have connected a J1939 CAN bus to CAN port 1. So check CAN port 1 and set protocol to J1939 protocol. In this instance, we have also wired a GPS to the GPS port on the CANgate. We select the GPS port tab, click Enable GPS port and set the baud rate to 19200. The default baud rate for most GPS systems is 4800. This particular GPS has a default baud rate of 19200. You will need to check with the particular GPS you are using to see what the baud rate is and what sentences it transmits. Click OK to close this panel. If you wish to access this panel sometime in the future, you need to select the Global tab and click the CANgate Setup button. We are going to program the CAN ports first, so leave row R1 column type as CAN1. Click the row R1 column wiring button. This opens the panel, the J1939 parameter selection panel. The first parameter we are going to set is the engine fuel rate, which is PGN number 65266. We can either look for this parameter in the list by its description or by the PGN number. If we click the parameter heading, this column will be resorted alphabetically. If we click the PGN SPN column, the table will be sorted by PGN number. Sort the list by the PGN number. Scroll and select the PGN number 65266 and select the engine fuel rate. Click OK. Note how a channel label has been automatically inserted. The first characters of the label are the abbreviated name of the particular PGN number. This abbreviated name, LFE in this case, is out of the J1939 specification. It is up to the user if they use this name or not. Send this short program to the DT80. Click Program Send to Connection. If there is already a job 1 in the logger, a warning may be generated by the system. Select the form window. ensure the Edit button is pressed in. Click R1 channel and select the engine fuel rate measurement. Click the Edit button so it is out. Note the fuel rate measurements being returned from the attached CAN bus. We will now add the engine RPM measurements. Switch back to the DT80 programming window. Click row R2 column signal and select CANgate. Click row R2 column wiring. Sort by the parameter column. Select engine speed. Set value type to average. Click OK. We could leave the channel label as it is. However, because in this instance we are going to select additional engine speed channels, we will need to be able to tell them apart. It would be a good idea to use a different name. In this instance, I will replace the EEC1 with AVE. This will identify the channel. I will repeat this process, except I will set value type to minimum. I will replace the EEC1 with minimum in this case. Repeat the process again and set the value to maximum. Change the channel label by replacing EEC1 with max. Send this program to the logger by clicking Program Send to Connection. You will need to click Yes to the warning. Open the form window again. Press the Edit button again. Select the engine speed, AV, min and max channels. Press the Edit button so it is out. We can see the values being returned from the connected CAN bus. We will now add the GPS measurements to the program. Select row R5 column signal and select CANgate. Select row R5 column type and set it to GPS. Click row R5 column wiring to open the NMEA0183 parameter selection. The protocol used on a GPS system is called NMEA0183. Select GPGGA latitude degree. Click OK. Repeat the process and select GPGGA latitude minute. GPGGA longitude degree. GPGGA longitude minute. GPGGA fixed quality. And finally, GPVTG true course over ground. Click Program Send to Connection. Click Yes to the warnings. Switch to the form window. Click the Edit button. Hold the Control key and select the additional channels to be displayed. We can now see GPS data and the CAN bus data being returned from the logger. We could now go on and add standard analog channels as if it was required. If we have a situation whereby we are not sure what messages are actually available on the devices that CANgate is connected to, there is a simple procedure to determine what type of traffic is available. Switch to the text window text1.dlt. Make sure the text window is also connected to the logger. Because dlogger can connect to multiple loggers and the text window can only connect to a single logger, we need to tell the text window which logger to connect to out of the list of loggers available. This procedure relies on the fact that we have sent a CANgate program to the logger at least once, and appropriate protocols have been set in the program that has been previously sent. There is a mode in the logger whereby we can connect direct to the CANgate through the logger. To enable this mode, we stop the logger by typing H, enter. You could have alternatively clicked dataTaker, halt, etc. Then we click the Serial Sensor Direct button. Now commands typed in the lower panel of the text window are sent directly to the CANgate, and data from the CANgate is returned directly to this window. Type snoopj1, enter. The CANgate will now tell us what J1939 traffic is available on the CAN bus connected to CAN port 1. Note the list of PGN numbers available on the CAN bus. We can reference these PGN numbers to see if the data we need is available. However, remember, just because the PGN number appropriate to the measurement you are looking for is present, it does not guarantee that the measurement will be there. There are a number of measurements available for each PGN, and you cannot be certain which are included in the data returned associated with that PGN. Now type snoop GPS. This is a list of the GPS strings available. Note we have GPGGA and GPVTG, the two we have used. There is also a snoop command which does not extract the PGN number from the address. This would be used on systems which do not use J1939, such as ODB2 systems in motor vehicles. To exit the Serial Sensor Direct mode, click the Serial Sensor Direct button. Restart the logger by typing G, enter. We can use the CANgate to very easily collect information from two independent CAN bus systems or a GPS if appropriate. This information can then easily be integrated with standard analog measurements that the logger makes. All of these measurements can then be either stored, sent via FTP, or collected by a Modbus-based system. The CANgate integrates CAN bus into the simplicity of the dataTaker system. The DT80 and the CANgate make a very powerful combination.